Hello everyone. We will go live, or we'll start the session at 8:30 in approximately 15 minutes. In the meantime, please introduce yourself. Let me know which clouds do you work in. Let me know which DevOps tools do you work with. What is your expectation from this session? And we will start the session in around 15 minutes at 8:30 p.m. IST. Right. So you can also let me know if you can hear me out, if the audio is loud and clear, if there is any other problem as such. Please use the chat window for that. We'll start the session at 8:30. In the meantime, let me know about your background. What do you work in? What is your job profile? Which tools do you use? Do you already work in machine learning, or do you work with DevOps? And hey, hi, Neeraj. So today we have more of a workshop. There will be if you guys have already joined us for the previous sessions, you must have seen the approach which we take, the case study based approach. We'll take the similar approach today as well. And we will have one customer scenario, and we'll try to solve that customer scenario. And we will create one MLOps pipeline with Azure DevOps and AML service to deploy that. And I'll walk you step by step into the process. And that's what we'll do today. So in the meantime, we still have we'll start at 8:30. We still have more than 10 minutes with us. In the meantime, please do introduce yourself. And if you have any specific expectation from the session, then let me know about that. And do tell me which clouds, which services, which technologies do you work with. We'll start the session at 8:30 p.m. IST. So welcome everyone. And sorry for rescheduling the session. It was supposed to be done 2 days back, but we had to reschedule the session, so apologies for that. So welcome everyone. We will start the session in some time. Please let me know about your background. What do you work in? Which technologies do you work in? Which clouds do you work in? Did you join us for any of the previous sessions? So we actually are running one series called as Tech Edge series. And as part of the series, we have covered multiple things. We started from the basics of DevOps. We started from Kubernetes. We started with machine learning basics, and then now we are moving into MLOps, which will combine all the previous sessions as well. So in case some of you who may not be watching this live, may watch this later on. You may also find on the same platform wherever you find us more links to the previous sessions, which will also add a little bit of background or fundamentals underneath today's session. So that's what we are planning, right? So do subscribe to the company's page so you can come to know of our events which we are announcing. I'll put the company page in the chat window. If you already are joining us from the LinkedIn, then that's the same page. But you can join Tech Scalable using the link in the chat. And little bit of background. LinkedIn live stream sometimes dips in quality. Like it doesn't behave the way it is supposed to behave. So that happens with LinkedIn Live. So just FYI, in case you have, if the quality dips automatically on LinkedIn, you can move onto the YouTube as such, and YouTube performs a little better right now in terms of the quality of the stream. We'll start the session in around 7 minutes. So please do introduce yourself. I'm putting the YouTube link in the chat as well in case something goes wrong with the LinkedIn stream, then you can simply switch to the YouTube version. So those who have just joined in, please introduce yourself in the chat window. We will start in next 6 minutes. And let me know about your background, any expectation from the course, from this session as such, from this uh, webinar which we are doing. And today we'll have more of a workshop as such, where we will be doing lots and lots of designing along with deployment. So we were running one series since last few months called as Tech Edge series, and as part of Tech Edge series, this is another session where we started with Kubernetes, we started with containerization, the basics of it, machine learning basics and everything, and then we are now combining everything together into the MLOps as such. And then we will have further, we have more sessions as well as part of the Tech Edge series. But thanks for joining in. And in case you have, if you are not aware of this series which is going on, you can join us on the company page, and then you will get all the updates about the series which is running. We'll start in next 3 minutes. In the meantime, please to introduce yourself to let us know about your background, anything you are expecting from the session itself. The agenda is there in the chat window. Please have a look at that. So we'll be discussing about what is MLOps, how do you use it, where do you use it, and then we'll solve one customer scenario, and it's more of hands-on today and the designing and the understanding part of it. So please have a look at the agenda. It's in the chat window. We'll start in next 2 minutes. So there is a question in the chat. Will the recording be available? Yes, the recording will be available. So if you are joining the session from LinkedIn. So Mukil, basically the same link through which you are joining in, the same link will be converted into the recording as such automatically by the platform. And whenever you want, you can come back to the same page and you can have a look at the recording. So the same applies for YouTube and the same applies for Facebook as well. So the same link through which you guys are joining in, that same link will convert into the recording link. Okay, so let's get started. And let me just quickly give you a walkthrough of the agenda which we are doing today. And then I'll walk you through the details as such and so on and so forth. So let me quickly find the slide. Okay, so check this out, guys. So today we'll be discussing about what is MLOps, and it's more of a workshop today where we will be deploying the entire pipeline using Azure DevOps and the Azure Machine Learning Service, but the concepts will remain same in future. Even if you work with any other platform, the the individual configuration steps may differ, but overall the flow will remain same. The concept still will hold because these are the MLOps concepts around any cloud or using any other DevOps tool as well. So we'll be understanding what is MLOps, what is Azure DevOps, how do you connect the Azure Machine Learning Service with in the entire pipeline, what is the why do we do it, how do we do it, when should we do it, and any concept around that. So whenever you have any questions, you feel free to ask. Now today's session is not really a very beginner friendly, as I was telling you that we were running the TechEd series since last few months, and as part of the TechEd series we have multiple different fundamental or foundational sessions which we did before this one, and now everything will come together into one, you can say, into one session or few sessions which will be there after this one. So so what I'll do, if you have joined me for any of the previous webinars which we have done, you must have noticed that we use a lot of things will remain more hands-on as such. We'll do the deployments, we will design it on the using the whiteboard, we will design the pipeline using the whiteboard, we'll go through the code, we'll go through the entire process step by step. And if I just give you a gist of what we will be doing in the first 15 minutes, approximately in the first 15 minutes, we will be sort of understanding the requirement of the customer, what is he looking for, and then we will be designing the solution. I'll walk you step by step uh, of what needs to be done, and right, what are we planning up, how do we have the code commit, uh, how will the build pipeline be created, where will the release pipeline will be there, what are individual steps in all these pipelines, and what where variation will come into picture in case you are working on NLP versus one day you work on any other, if maybe you have computer vision versus NLP, then where the variations will be there. uh, for example, how will you register your data set, how where differences will come into picture. So this session will be mostly hands on. In case anyone is looking for doing it in their company, or maybe you want to deploy this as part of your learning project or something, or maybe a capstone project, then you can simply walk through these steps, and it you can recreate the entire scenario, right? So as I was saying, that we'll understand the customer requirement first, we will understand the solution first. If the design is clear, implementation will be way straightforward. If the so we will invest some time into the designing part, we'll understand how it's done, like what's the flow of it, how do we do it, and we will use the whiteboard to understand it. Now before I start with the session, let me introduce the company itself. Let me tell you a little more about us. So we basically provide services in multiple domains. We provide training and consulting services. We focus on cloud, DevOps, machine learning, data science, AI. Uh, we are the if so in case you are looking for any services in these domains, in case you are looking for any training, you are looking for any you can say you want to focus more on the machine learning part of it, or AI part of it, or MLOps part of it, we have various training programs around that. We also provide consulting, so you can reach out to us. The numbers are over here where you can contact us, and basically, if you have requirements, you can put it forth. Now, a little about me. My name is Shivam Sharma. I am your speaker for the day. I co-founded Tech Scalable, and this is part of the Tech Edge series, and we will be talking about MLOps today. So as we were talking about, let's first focus on the problem statement. Let's have a look at the customer requirement, and then we will go through the solution. Now, Smita is saying the screen is little blur. Smita, hopefully check out. I think that might be from your end as well, because you are already joining in from YouTube. YouTube is the one where the stream is of good quality. On LinkedIn, it may happen automatically. So those who are joining us from LinkedIn, there is a link on the company page, on the event page, in the chat also, where you can move onto the YouTube stream if the quality dips. It happens automatically. It's not in our hand. I have seen it before as well, right? So yeah, all the recordings will be there, and let's get started. Please, let's focus a little over here first. Let's go through the customer requirement. So problem statement first, we'll go through it, right? And we'll see why this customer needs MLOps, where does this customer needs MLOps, how are we going to provide him the solution for it, and then we have to deploy the entire scenario for this customer, right? And we have around approximately 2 hours with us, so we'll jump into the deployment very soon. So basically, the customer is called as wide world importers. It's like they are a pretty giant company. They focus on it's a manufacturing company itself. They focus on and they have multiple products which they are manufacturing. They have multiple factories as well. They have approximately 10,000 sensors in every factory, uh, and they have 5 of them, so overall 50,000 sensors are there, and the data is getting streamed right now in real time. Now, apart from these sensors through which the data is getting streamed to this customer also has a big, you can say, stake in the vehicle market as such. They manufacture the vehicles as well. So a lot of times, what happens, like you can relate to it. Now when you go to any technician to get your vehicle repaired or for any servicing as such, basically the technician has a long series of steps which they do, in which they sort of do the diagnostic of your car. They check out why they take out the telemetry data as such. They run various tests on top of it. They also have visual inspection of it, and they also do some sort of like what we call as through using their experience, they try to find the problem in the car. So what this customer also get is, apart from the sensor data, apart from that continuous stream which is coming in from their various factories, they are also having these web applications through which the technicians, when they do the diagnostics of the car, they use that, they fill up the you can say form in natural language, or you can say they write in any language as such. So what this customer is looking for is that the uh, whenever the technician manually or sort of humanly write the description of what has gone wrong with the car, we have to do NLP on that. We have to basically understand what's the problem statement, what is it talking about, is it even possible for us, is it compliant, non-compliant, is the parts available, which parts are there, what may be the root cause of it, and so on and so forth. So that's basically we have NLP requirements over here, and we have stream problems as well. Data is coming in from multiple locations, from multiple websites as well, and uh, that's the overall gist of the from how we are getting the data. Now, today we will be focusing on the MLOps of the MLOps part of this problem statement. In the previous sessions, I really have focused on the other parts as well, like how will you get the stream, like using any Kafka based cluster, how do you get the stream as well. So today the focus will be on the MLOps part of it. Now, I'm pretty sure you already work in machine learning, and this any if you talk about any machine learning pipeline, there are few common steps which are there. We have to prepare the data, and in case you talk about the natural language processing, then the data preparation is one of the biggest tasks which we have to do, where you have to basically convert the text into some sort of embedding or numerical output which the models can run, understand, and train on. So data will be getting ingested. So if I just go through the entire problem statement for this customer, we have to ingest the data will be there in multiple locations, stream and as in batch mode as well. Prepare the data, normalize it, transform the data, validate the data, do feature extraction on the data. During the build and train of the data, we have to do hyperparameter tuning, model selection has to be done, model testing has to be done. If the model which we are training right now is better than the previous version of the model which was already deployed, imagine like there was one model already deployed in production, and now you retrain another model. So we have to make sure that the model which has been retrained is supposed to be better than the previous one, then we should we deploy. Otherwise we don't deploy, meaning if you train another model and when you do the evaluation, that model doesn't comes out to be having better performance than the previous one, then there is no point of replacing the previous one as such. It might be it will do more damage to you. So how can we automate that? Like manually you can have the using the evaluation matrices, you can check it out. You can literally say that, okay, is the accuracy better, precision better, recall better, is the less we have less error or there or not. But how do you automate that? Using one DevOps pipeline. That's what we will also focus on. Now, if you talk about deployment of the models, we deploy the models in for example, we have various environments. You deploy in the UAT, then you have the dev UAT, then you have the production itself. So how do you if you develop something, how do you automate the testing, and how do you then deploy it in the production environment in a very smooth manner? That's also something which we have to focus on or understand or discuss as such. That's what we will be doing today. Now, if there is any problem in the problem statement of the company, then do let me know that what are we talking about, because this the initial discussion which we will have will be very important in terms of how do we take this problem forward, how do you design the solution. So today is the MLOps part of it, right? So we'll design that, uh, the build and the release pipeline. What are the individual steps in it? What's the meaning of the build pipeline? What's the meaning of the release pipeline? All of those things we'll cover it on the way, right? Now, what I will do, I will show you the overall architecture which we are proposing for this customer from the point of view of MLOps, and then I will break it down on the whiteboard and we will deploy it individually, right? So I'll show you the entire architecture first. It may be overwhelming, it might look pretty big, it might be having a lot of steps, but then we will take it step by step and we'll break it further. So if I just show you the architecture, let me do that first. So have a look at this. So for this customer, see, the when you design the pipelines, the 90% of the logic will remain same. There will be variations in different problem statements. If you are doing something for different sectors, different domains as well, if you are doing something for different if you're doing something in, let's say, using TensorFlow, if you use maybe PyTorch, if you use NLP versus you use maybe any other CNN, RNN, or transformers as such, whatever you use, there will be some variations, but overall flow will remain same. So this is at a very high level flow where we have various, like the quote is the see, if you notice over here where I'm just putting my cursor, the code will be checked in into the repository. We will build some pipelines. We will have a release pipeline. We will release in the development in the QA environment first, and then we will release in the production environment after that. So we'll use ACI, AKS. Some more things will come into picture. Now it will be easy for you to understand this diagram if you work in Azure platform. If not, then don't worry. Anyways, I'll walk you through the individual steps, and you'll get a pretty you will understand what we are talking about. So what I'll do, I'll open my whiteboard and I'll first give you a walkthrough of what we are doing, a little more in depth, and then once the design is clear, we will relate this design with the problem statement. When that is clear, we will start with the deployment. But this is what we are doing today. We will create the build pipeline. We'll create the release pipeline. We will have the release pipeline do. We'll have two stages over there. We'll deploy into various locations. We will containerize the machine learning models, and we will have the monitoring done on top of it. We'll use Azure Application Insights to do the monitoring, and we'll understand what's the meaning of it, right? And so on and so forth. So in case you have any questions, put them in the chat window. I'll just quickly open my whiteboard and I'll take you forward from there. So this was one backup which I have created in case we run out of time. Then we can just go to the backup and maybe sort of just go through it. But I'll just give you a walkthrough of what this customer is looking for and what we are providing to them and the meaning of it. Like, how do you do it practically? The steps as such, like step 1, step 2, step 3, and so on and so forth. So if you practically think it, like we have, so I'm pretty sure maybe most of you or all of you already work in the data field as such, data platform. You might be data engineers, or you might be AI engineers, or you are uh, you might be data scientist already working for you can say, and as the introductions already say, a lot of you already work in these fields itself. So when you get that particular uh, what I'll do, I'll just quickly increase the screen size so you can focus on the screen a little more. Give me 1 second. Okay, right, perfect. So what we will do, we will just like I'll walk you through these individual steps, and then we'll do the deployments of it. Questions in the chat, please. So I'll take the questions on the way. So the very first thing is, now this is where we are. Let's say, imagine this is where you are. Now you will use various development environments to write the code which will do the model training, model registration, containerization of the models, evaluation of the models, and so on and so forth. So the very first problem is we need that like we need the editors like Jupyter Notebook, or we need Visual Studio, Visual Code, VS Code. We need PyCharm, or or any other editor or IDE of your you can say IED of your choice. So basically, where uh, uh, you can say, where using that you will do the code as well. So let's put some maybe Let me just put, let's say VS Code is here. We have VS, we are using VS Code. Maybe we are using Jupyter Notebooks, right? Or you are using any other thing. You have PyCharm with you, or you have uh, any other environment of your choice over there. Now, let's say we have PyCharm, charm over here. Let me put it like that. So now the very first thing we develop the code. Now the session which we have today is focusing a lot on the Azure side of the deployments. So in Microsoft Azure, we basically have the development environment already available in the cloud. So what we will be doing, we will be using one thing called as Azure Notebooks. So these Azure Notebooks are available as part of one service called as AML service. We have Azure Machine Learning Service over there, right? Like this. So using Azure Machine Learning Service, we will use the development environment over there. Now, what is a good thing about it? Basically, these notebooks are available in the cloud. You don't have to keep the code or environment in your laptop. Things are more, you can say, are inside the network boundary of the company. And we can enforce various type of security policies and so on and so forth on top of it. So the development environment is basically part of the Azure Machine Learning Service. So what you will see, or what we will do very soon, is we will create something called as a compute instance. So what this compute instance will do, this compute instance will basically is where we will write the code, right? Where the developer, where the data scientist will write that particular training, evaluation, registration code as such. Now, whenever you work with whenever you develop anything, we require repositories to uh, check in the code. So you can use GitHub, you can use any other repository which comes to your mind. What we can also use is, in Azure we have one concept called as Azure DevOps. As part of Azure DevOps, we have repositories over there. So inside the Azure DevOps, we will use the repository concept over there, where we will check in the code. So this goes like that, right? So this is where the check-in will happen, the code check-in. So we will do this deployment in few minutes as such. You will see that we will go to Azure DevOps, we'll do some prerequisites over there, but in the end we'll use the repos over there. Now this is from this point onwards is where the entire flow will start. So what we have to do is, we after this step, this is what where we will put the trigger. So we will say that, okay, whenever we create any model, whenever we create, not exactly model, whenever we whenever we check in the code, whenever we uh, modify the code, this is when the pipeline should get triggered. So what we have to do is, we have to put some trigger on top of it. The trigger can be manual, trigger can be automated as well. You may have to manually go and trigger it, it may just happen on the way itself. So both options are available, we'll explore both the options as such. Now, after this is where the build pipeline will come into picture. So this is where we'll put the build pipelines, right? So here, this is called as, let's say, Azure build pipeline. Now, as part of the build pipeline is where we will do the model training. This is where we will do the versioning of the data. This is where we'll deploy you can say, we will do the infrastructure deployment. The infrastructure as code part is this is where we will put that into picture. So let's say this is the Azure build pipeline. And what are we planning of doing with this build pipeline? Couple of steps. First, deploy any infrastructure. So what do you mean by infrastructure? See, if you train any deep learning model, you may require that GPU cluster, right? Because to if you, or if not, you may require that CPU cluster, or maybe one single machine or whatever. But we require that infrastructure. We need the clusters as such to do that. So we need to deploy that infra. Apart from that, you may also require other locations. When you train your model, you also require one repository to save your model inside that repository, because it's something, see, in a team, multiple people will be training the models, and then we need to have version control on top of it. So we need to deploy those locations, we need to deploy those services where we can keep the trained models. So that will also come as part of the infrastructure. We also have to do the model training, literally where the training happens. And one more you can say big steps which we need to do is we have to evaluate the model. So these three things is what we are planning of doing as part of the build part of the pipeline. So you will notice that these three things is what we'll do, right? Now, a little more into depth. Let's jump inside it. So how do you do it? Like the practical steps I'll show you, but let me just give you the gist of it first. And then when we'll start deploying, we will come back to this diagram and we'll relate to it. Like, is it working out or not? So the very first thing is, see, if you write any step, it has to execute somewhere. We need some sort of agent or some sort of build agent where those steps can execute. I can so that environment where we are executing is called as that like we have the agent concept. Now these agent can be hosted by Microsoft, these agent can be hosted by the customer also. If you require customization on the agent, customization such as you want to install Python, you want to install maybe pip, you want to install conda inside it or mini conda inside it, then that type of customization is where you require the machine to be created and hosted by the customer or by us inside the Azure or maybe in some other location which can be accessed by the build pipeline. So what you will notice is what we will do, we'll basically create one Linux machine, right? So we will make one Linux machine, and this Linux machine is definitely is what we will have to pay for. Like when it runs, when you run your pipeline, it we have to pay for that particular machine as such. But this is what is called a self-hosted agent. So this is self-hosted agent. We will do some customization into it. Why do we need the customization? Because we can run our steps over there. So that's one thing which we have to do, create one Linux machine and do some customization inside it. Once we have done that, this is where the next step will start. See, now if you work in Azure platform, we have Azure Machine Learning Service as one of the primary offering from Microsoft to train your models. Why? Because we can design the MLOps pipeline using it. So what we have to do, in case you have the Azure Machine Learning Service with you, then you use it. If you do not have the Azure Machine Learning Service with you, then you create it. So before we can train the model, we want to create the AML service or we want to use it. So the second step of the build pipeline will be we will create or we will use the existing AML service in Azure. Now, as we were just discussing, that what happens, how do you train the model or where do you train the model? If you practically think it through, we need the clusters with us. We need, if you have big data, you may do some model parallelism, maybe you do some data parallelism, but you need some compute location to be there. Now, what AML service does, as part of AML service, we can deploy these clusters. See, uh, if you have heard about Databricks before, the Spark cluster, right? Databricks is pretty popular. This can also be that, like this compute cluster which I'm creating over here. This compute cluster can be you can say a CPU cluster, this can be GPU cluster, it can be Databricks also, right? The Spark based cluster as such. If not, then don't worry about it, forget about Databricks. So now uh, so that particular cluster needs to be created or started or initialized or any other word which you want to use, but we basically need to use that cluster. So that needs to be deployed or used, right? So whichever cluster which is available or whatever cluster you want to create, you create that. So we create the cluster. So this is where we create the AML cluster, let's say compute cluster. This is where the model training will happen, right? Your deep learning models will train over there, classical machine learning models will train over there, anything which comes to mind is that is going to happen there. Why there? Because of the cluster property as such, you can have model parallelism or data parallelism. Now once we have trained the machine learning models, see, where are you going to keep that models, like those pickle files which you have, those the saved models? If you know about open neural network exchange, ONNX model, we will be talking about it today. But those pickle files, where are you going to save them, right? So we need those locations where the pickle files can be saved or where the models can be registered. So as part of the build pipeline, what you will also deploy is, uh, so as the next step, you will run your model. Let's say run the ML pipeline. What this pipeline means is like the training and the evaluation pipeline, like multi-step pipeline. If you are doing processing on your data, this is where that pre-processing of the data will come into picture, which will be pretty much required in case of natural language processing. Now, the trained models needs to be registered. We register it somewhere. And if the model is good enough, we also have to do some containerization on top of it, so we can run those Docker models inside the Docker containers. So all those steps is where we'll be doing that. Now I'll just quickly break this particular step. I'll start with the deployment very soon, but you have to understand the flow, because when we start with the deployment, we'll come back to this flow again and again to understand where till where have we done it. Now, uh, right. So now what do we do? If I just break that step little more over here, so we will use the Azure machine learning service. So I'll make the same box again. This is the same box which is there in the bottom of the page, right? So there's the same box over here in the bottom of the page. Is we are just I'm just putting it here, AML service. Now inside the AML service, if I transform my data, I have the capability over there to register my data. Register my data means I can version my data. I can put like, okay, this is version 1, version 2. Maybe you can also have the raw and the transform, the processed data in different versions. So we have two concepts inside machine learning service which we are not discussing today, but just FYI, we have data sets over there, and we have data stores over there, right? Data stores. So that is available, versioning of the data. Secondly, we already talked about the cluster. Using the compute cluster, we will do the model training. Once the model has been trained, we need to save the model somewhere. So we have a model registry also available. As part of the model registry, you can version your models, like let's say version 1, 2, 3. So after 1 month, you have no idea which model did you train before, like last month, right? So you need that repository. You need the tags also, like what did you do, what did you thought, which this model is having, which what hyperparameter value did you used to train the version number, let's say 2 versus the version number 3. So right, what learning rate was used here versus what learning rate was used here. That all that information can be saved as tags along with the models, or as description as part of the models uh, over there. So if I just break that step further, now to train, we need the training code as well, the code which was checked in, right? If I just take you back over here, we checked in the code, right, in the repository, that code. So what do you require? The generic terms which we use is like the train.py file. So there is a training file. So here is my train.py file. And then this is where maybe evaluation. For evaluation purpose, we have another file, evaluate.py over there. So uh, using these, we will do the evaluation and the training over there. Now in this evaluation, what we have to do, if the uh, if the new model is better than the previous version, then you register it. If not, then don't register it. So here we need that logic, like if the new is better than the old, then register, right? This is one generic concept which I'm saying. I'm not saying you will always follow what we are talking about right now. You may go in your own directions, but that's the overall thought in this. Now we after that, we also can use the containerization to containerize it. Now imagine the model which you trained was better than the last one. Let's say it was better, right? Then if it is better, then we have to talk about deployment in some point in time, like where will you deploy, and so on and so forth. So This is where I'll just go in this direction. So the model which was trained, now the next problem is the model. Let's say imagine version 3 was the best of the best model, right? This is the best one, the latest one, which is anyways it is registered. It means it is better than the last one, anyways. So now we have to deploy this in the some location, in some production location. So now the problem is the if we can decouple the underlying environment from the dependencies, or if we can package the code along with the dependencies, the overall functioning becomes more smoother. So the approach which is recommended, or what we will be doing today, or what you should be doing is whatever model you have, containerize that, put them into, you can say, make one Docker image out of it, store the Docker image somewhere, and then deploy it later on. So what you will notice is that, imagine this is the Docker image over here, this one, right? The Docker image. Now what is this Docker image having inside it? Version 3, v3 over there. So this is the model v3, ML model version 3. What was it used to train? What did you used? Maybe you used TensorFlow, maybe you used any other dependencies. As such, all the dependencies are there inside this Docker image. There is one concept called a score file. I will explain that in some time, but this is the score file, score.py, score file basically. Now see, you will not be the only one who is in the team. Secondly, we might not be the only one who is doing the deployment. There will be other team members as well, right? There will be multiple models. You might be working on NLP part of it, tomorrow you may have to work on something else. So we need one repository where we can keep this Docker image, where you can do the versioning of the Docker images, where you, based on the requirement, you can do the deployment of the Docker images. Now you guys must be aware of Docker Hub as such. Definitely you can use Docker Hub or any other repository which you use in your company, or if you know about, you can definitely use that. But the recommendation is, if you are working in Azure, then we already have the repository available where you can keep the images. And why do we recommend that? Because it is part of the platform. We can put network on top of it, we can do that private integration with your PaaS solutions. Like traffic doesn't even go outside the environment, like it internally talks to the PaaS solution. So highly scalable, uh, private connectivities, and more security, right? And serves the purpose. So the repository which we will be making today, or I recommend you use if you are working with Azure uh, DevOps solutions, is ACR. So this is called as ACR. So ACR stands for Azure Container Registry. So this is Azure Container Registry, right over here. So what is ACR? ACR is that repository for Docker images. So this is where the repository, like the repository part of it. Now, repository for images, right? I'm not deploying it there. We are just storing it. So what we will do, we will version it. Okay, so this is the version maybe 2 of this image, the one which is better than the last one, or version 3, or whatever version it is. But we want to work with that particular version. So now the next problem is the deployment part. Like you have the best model containerized, stored in the repository. The best next thing is like where and how to deploy it in a automated manner. But before being deployed into production, some human intervention should be there. So this is where we will have the release pipeline in picture. So this Docker image will become the artifact which we are thinking of. Like you must have heard about the word artifacts, right? Artifacts are the outputs, like whatever. So right now the trained models are the outputs for us in the machine learning world as such. So the output over here of the build pipeline is basically the build artifact. Is I'll put it like this. Let's say build artifact, and let's say like this. And what is the build artifact? That's the build artifact for us. This build artifact will be used in the next step where we will do the deployment over here. So this is where the release pipeline come into picture. Like, see, you trained it, amazing, now you have to release it. So when you release it, you do not release directly in production, you need to test it out first, like is it even working out or not, right? Is the score file properly coded or not, or what is the initialization function over there on the run function, is it all those things. So now the next step which we are proposing to the wide world importers, or what we need to make, is this box over here, which will very soon become the release pipeline in the Azure DevOps portal. So you will notice that we will create this, and I will just quickly put the words. Okay, now obviously you require, if you develop something, you require some location where it will run. So where is that location where it's going to run? That will be the Linux VM which we created in the previous step will come again. So the Azure DevOps the pipeline will execute in this environment over here. So we have to pay for this Linux VM, and but we will use the same one. So this is the use the previous Linux machine over there as such, and this all the dependencies will already be there, or reinstall it or anything like that. Like right today we will be using the same machine. In your environment you may do something today, maybe your release pipeline triggers tomorrow, so there is no point of keeping that machine running, right? You may turn it off. But this is that self-hosted agent. Why do I need self-hosted agent? Because I can customize it. I can do that in Microsoft hosted agent. The customization options are limited as such, versus what you can do in your own machines. So we will use the same machine again. Okay, now the pretty straightforward 2 3 you can say steps will be there. Now the we need to deploy. Now for the deployment location, we are using one thing called as Azure Container Instance, ACI. That's the short form. If you work in Azure, you know it. If not, then don't worry about it. I'll anyways show it to you how it's done. So what are we doing? See, this ACI can be used for the development environment. We can also use this as part of the you can say QA as such. Overall we will do the testing first, and then we will put in the into production. So let's say there is a stage one. So this is stage one for us, and then we will have one more stage after it, like to release in production. So you may have more stages as well. I'm not denying anything, I'm just, you can say, showing what we are deploying. If before you deploy something in production, you would like to have another look at that deployment. So that another look is this human intervention, where we will say that pre-deployment. So this guy will do the pre-deployment approval. So over here we will do that like this, pre-deployment approval as such. How can this approval be done? This approval can be triggered or notified, or notification can be done through email. That's one method which we'll use to do that. Now how will this work out? Like if we made it over here, just to further elaborate, you see this ACI. So the previous registered image which we had, the image which we had registered in the last step, that registered image is what we are using now, something in this manner. And we will create Azure container instances. Now Azure container instances are, you can say, is one service. ACI is one service in Azure, where if you don't want full-fledged orchestrator, if you don't want that full-fledged Kubernetes environment, then you can definitely use the ACI, which might be the simpler location to run your containers. So this is Azure container instance, right? Let's put it there, instance ACI like this. How much RAM do we want? You can specify all that. Today we are happy with 3 GB of RAM. We'll give it few CPU cores. I will confirm it. I think 2 CPU cores and so on and so forth. is what we will give to this machine over here, and give to this instance. And inside that is where we will have the Docker image. See, so this is the Docker container right now, not the image. This is the running Docker container. That's your version 3 of the model, all the dependencies and the score file. Now we also would like to have a testing, would like to have the testing done of whether it's working out or not. So the API endpoints will be opened. See, this is the API endpoints. And then you can definitely have a test notebook where you can do the API call to that particular model and you consume it. So this is that request response. So the API call is done. This is where your x1, x2, x3, and so on and so forth will go, and so on and so forth, like this. Your the dependent variables, the attributes, and all that. And the score file, what it will do, it will put everything into an array and will do the model dot predict like that, and whatever output comes back will be thrown back. So this is the y dash, right? So this is the y dash as such right now, the predictions, like that. So if things work out, imagine everything worked out, it's performing great, and so on and so forth, whatever you were expecting is what it is behaving like. We would like to deploy this in production, right? We would like to deploy this in production as well. So once we have done the testing, comes the production stage. Now this is where we this is where you have multiple options available. Now I'm not saying you can only deploy in AKS or Kubernetes from Azure machine learning service using the DevOps portal of Azure. I'm not saying you can only deploy there, but these are one of few of these stages or few of the locations where you can definitely deploy, right? And anything else which comes to your mind, you can put in the chat window. I can confirm it for you that can you deploy there or not, right? So the Kubernetes in Azure, or Azure version of the Kubernetes, is called as AKS, Azure Kubernetes Services. There are n number of added benefits of having it or using it or running it. It's a totally sort of, it's a you there is it's a type of managed service where you don't have to manage the master node. You have to work with the you don't that management of the master node, the high availability of the master node, all those things are taken away from you, and they have given way more options for you to work with. Now so imagine this is the AKS cluster. We are not deploying any new cluster. It might be existing cluster in your company, and you may run few pods over there where the model will be deployed. So this is my diagram representing the AKS cluster, something in this manner. So Azure Kubernetes services. You may also, if you don't require that full-fledged orchestrator, if you don't require the auto scaling, auto healing, if you do not require the features or benefits which comes with Kubernetes, or if you are not running any AKS cluster and because of the cost consideration you do not want to run this, you can obviously use other locations in Azure as well, including ACI, including Azure Web Services, web apps, and so on and so forth. You can run it. The containers can run in many locations. Now, wherever you run it, it is absolutely required you monitor it as well. If tomorrow there is a data drift, if the degradation happens, you should be, being the data scientist, you should be the first one to know that the degradation has happened. So this is where that monitoring or continuous monitoring comes into picture. And for the monitoring in Azure, we have Azure Application Insights. So Azure Application Insights is basically does, as the name suggests, does application insights. It works in that particular domain or field. So over here, now what we will be doing today is we will create one application insights, you can say workspace, and all the logs which are coming from here. Now the logs or the telemetry data might be some sort of metrics also, like is the model running, is the container still running, not running, crashed, something happened with it, uh, how many API calls came, what was there in the API calls, like what was the input, we can also log that, right? What was the input and what was the equivalent prediction made on that input, So the model did this prediction. Whether it is correct or not is something which you need to check further, but we can log all of that. Now, as part of the logging process, you must be or may be aware of the object storage which we have in Azure called a storage account, right? That guy. So this is the storage account. So storage account is one of the go-to location where these application insights also store data. In case you also do logging directly into storage account using application insights, we can create the dashboards on top of it, right? So this is where the dashboard comes into picture, let's say here. So imagine something like that. So this is what we are suggesting to this customer, that you use any you can say any development environment of your choice. You use any IDE as such, PyCharm, VS Code, notebooks. Today we will be using the Azure machine learning notebooks. So I'll start with the deployment now. Whatever we have discussed is what I will deploy, and I will show you the individual steps. We'll put the triggers when it is required, right? What trigger, what, and all that. We'll have the Azure DevOps repo created. We'll have the build pipeline also in place. We have to, you can say, create this Linux machine, configure it for the self-hosted part, uh, and right. And apart from that, we will create the Azure machine learning service. We will create the compute clusters. We will run the machine learning pipelines. We will do the train.py file. We will use the evaluate.py. We will register the data. We will containerize it. We will have the release pipeline created, and we'll do the ACI deployment, then we'll do the deployment in production, and then the application insights. That's what we are starting with. So in case you have any questions in mind right now, feel free to put that in the chat window, and I'll just go through your questions. And in the meantime, I'll start with this. Okay, let me see a few questions as such. Okay, so instead of AKS, are we using ACI? If we see the problem statement, it may require high throughput output processing also. Will it fulfill the solution? If it doesn't fulfill the requirement, use AKS. No, no issues. The containerization process will not change. This will remain pretty standard over here, this part. You deploy it anywhere you want. Decoupling, that part. Okay, so let's start the deployment part. In case, and we will come back to this diagram, and we'll walk through this diagram. I'll also open few maybe a couple of notepad instances. I will put some steps there as well, like step 1, step 2, step 3, step 4. So it will be easy for us to see the entire MLOps pipeline getting deployed and also track where we are. So if this design is clear, the deployment will be clear. If you have confusion in the design, then it's the right time to ask, right? Okay, so in the meantime, I'll just quickly open my Azure portal, and let me just close this for this point in time, so I can open the Azure portal as such. There is one thing which I have done. I haven't done any configuration yet, but I have sort of uh, created the Linux machine already. Just to save some time, there is no. I'll show you. There is no for much logic in how to create a VM in Azure. You can just Google it up. But the configuration I'll show you. Like how do you configure it? How practically will you do it in if you have to do it one day? Then how what do you do over there? That part will cover, right? So let me just maximize the screen and we'll do the deployment. Okay. So okay. Now I'll just open few instances of the Azure portal as well. So I don't have to reload the pages. And this is the Azure DevOps page. We'll use it in some time. So I'll do the deployment over here, and I'll show you step by step. We'll relate with the diagram, right? What are we doing? Okay, so if you see, we have to deploy the AML service, Linux machine, uh, the other things, ACI, AKS, some clusters to do the training over here. and so on and so forth. So all of those things needs to be done, right? So let's get started with it. Now, if you work with Azure DevOps, there are few things you need to uh, as part of the prerequisite. You need to do something. Just give me 1 second. Let me find my Azure portal and see. Okay, great. Now we can switch these screens pretty quickly. Okay, now okay, notice this. So I'm creating one machine learning service, and we'll do it a little parallelly. So I don't want to spend your time into looking at this deployment. So we'll do things parallelly, but you can all obviously one day do that. So I'll just give it a name, Shivam's AML service, if the name is available. Great. Southeast Asia is good enough for me. Uh, Run it there, no problem. So we will just click on create. Now we also require the Kubernetes cluster. So let's make that. Right. The only problem which I have is that if what I'm trying to do is I'm trying to make things, and on that way I will explain it. So it doesn't takes extra time. So that's why we are doing things, you can say, and using it later on. So it doesn't take 10 more minute later on to uh, do the deployment of things, right? Hopefully you are understanding what I'm saying, because we just want to save time and finish this thing in next 1 or 1.5 hours. So AKS cluster Southeast Asia is good enough. I can definitely go for high availability. Right now that's not what I'm thinking of, because it's my dummy account. I have to pay for it and all that. So I would like to keep the instances less. One node cluster. You in production, go for it, go for 100 node cluster. Right now I'm just going for the smaller one. Okay, so this is where Kubernetes is coming into picture, and I think the rest is fine. Let me see, did that executed? Okay, so I'll just click on AKS over here. So what is this? This is that coming up. See this part, the deployment location, that one, right, which we have to use later on. That is coming up. Got it? So I'll just click on create, uh, like this. And in the meantime, I'll just go to my Azure DevOps portal, and I'll create one, you can say one project here. Now what I have done, I have clicked on the organization before, and in this organization I have clicked on the Active Directory before, and I have connected my Active Directory. If you know about Active Directory, then you understood why I did it. Like Active Directory is that IAM part, right, where everything get authenticated and authorized. So if Azure DevOps want to deploy something in Azure portal, obviously it needs that rights. So we need some sort of interaction with the Active Directory. This is that part. So I have already done this. For you, it will not be there. You just click on it and say connect. That's all. Right. I can disconnect and show it to you if you want. Now, what I'm doing, I'm just going one page back, and let me just quickly make that project. So I'm giving it a name, MLOps, like that. I'll zoom in a little bit. It will be easy for you to have a look at it. So nothing special here. I'll just click on create project. Now, when you work with Azure DevOps for machine learning, there is one extension which needs to be installed. The extension is available on this page. So if I do not install this extension, then the uh, if you notice over here, like you see this, like we want that the build artifact should be the trigger to the next step. We want this to interact with the AML service. If I don't install that extension, that will not happen. Interaction between Azure Machine Learning Service and Azure DevOps Portal will not happen. So we have to install some extensions as such, which we are doing over there. Now, if you notice, I have already installed it. It doesn't take much time, but actually I just wanted to check out my deployment. So as a backup, I did it once before. So because of that, it's showing that it is already installed. But here is a install. Here you will get one install button. Just click on it. Okay. Now I'll close it. So these steps are for somebody who will watch the recording one day and will try to redo what I'm doing. Right. Those steps were for you. Now I'm inside the Azure Machine Learning workspace. We'll come back to here. I'll just quickly want to run few more things parallelly. So this is my Azure machine learning service. This is this box. You see this purple box, this box over here, this purple box here, right? This is that service. What I want to do is I want to create the cluster. The cluster creation also will take few minutes to do. So I just want to save some money. I want also save some time over there, and I will do this like cluster creation. And we will use this cluster later on. We'll use the same cluster. Whatever we name we give, we use that one. So what I'm doing, I'm creating this purple machine learning service plus the cluster over there, and plus I'm creating the compute instance. So I'm creating this, the development environment, the cluster, and the service is already there. Inside that, I'll create those two things, right? Three steps are going on right now. So please, so this is my machine learning service, the purple box. Now I'm clicking on the compute and compute instance. This is where the code will be written, right? The code part. Uh, Name is good enough. Let me see if I can put another name there, and hopefully the name already exists. Okay, somebody took the name. Okay, two is available. Great. Southeast Asia CPU cluster, and how much cores do you have? So every subscription will have some quota limit. In your production you may have no quota, but in my demo subscription obviously I have some quota, so I will respect that quota, 20 core quota. So 4 core 14 GB RAM. I think today I am okay with 14 GB RAM with even 2 core. If definitely one day you may require big machines, you can click on that option. They are giant machines available, use them. So what I'll do, I will just say okay, create, and I'll in the meantime I'll click on compute cluster over here, and I will I'll create that. So what did I do? I What is this compute instance is this one over here, where the notebooks will be there, right? What I am showing you now is the cluster part over here, this part where the training will be done. So okay, so this is that compute cluster over here. I'll say next. Southeast Asia is okay. We don't have any problem. Even you can change the location. Like in case you want to have, you may have the compute. See, your data might not be centralized. It might be in different Azure regions, and you would like to have the cluster near the data. So if your data was in the storage account and the cluster was in storage account was in US, you would like to have the cluster also in one US region to reduce the latency and the data transfer cost. So you can do that. That's what just is available, like you can do that. And I am just going for the same size, and we have 18 core left now because we used two of it. So let's maximize the nodes. Let's have three nodes over here, so 0 and 3, and we have to give it a name. So I'll give it a name which I have used in the script, AML cluster, like that. That's the name I have used before, so that same name I will use here. Okay. So what is this? This is that the red box over there. Earlier one was the compute instance. Okay. Now these, they will take some time in getting created. This will take maybe next 4-5 minutes. This will come up pretty quick, but will take time later on when we will run it. We are not paying for it right now. We will pay for the compute instance as soon as it comes up. So we'll come back to these in some time. Let's move ahead. So right now I'm back to my Azure DevOps project here, and what I want to do is I would like to configure the Linux machine. You see this Linux machine which we have. We want to configure that, the self-hosted agent where we can do the customization. So to do this part, I am just basically going to my Azure MLOps project. I'll click on project settings, and I will click on the agent pool here. And we don't have anything. We'll say we have some default options over there. And what we'll do, we'll say, oh, give me 1 second. Let me try to. Okay, I'll add one pool, self-hosted, and I'll give it the name which is used in this script later on, we'll say that you are called as agent pool. That's the name we are giving to it. So let's put say agent pool. We don't have any machine there. Just let me confirm that. Which user account is this? Oh, I think this is my the previous one which I created. Okay, no problem. So I'll use that, but it has been deleted, so I have to reconfigure it. If you see, this is sort of showing offline. So let me do one thing. Let me say new agent because we have to do the reconfiguration. So we are using Linux for the self-hosted agent. You can also use Windows and Mac OS over there. I'm using Linux. This is the machine where the build pipeline or the release pipeline will execute. This machine, the purple one, the first one. So there will be few steps over there. Let's do it. Now, if you notice these steps over here, we have to create one directory. We have to move in the directory. We have to install the agent. You can, if I click on it, it will download it inside my machine. But I don't want it to be in my laptop. I want it to be in the compute in the remote VM in Azure. So I'll just sort of get it into the machine. Now then we will do some configuration there, and then we have to run that particular agent to be listening to the job. What is the meaning of listening to the job? You will notice. So I'll go to my machine. This is the machine over here, and I'm pretty sure it might be not very visible. So I'll just open my notepad here, and I'll show you what we are doing in the notepad. And that same thing is what I will do over there. So what do we require? We require Azure CLI. That's one thing which is required, Azure CLI. We also require Python in this machine. We also require pip over there, right? Pip is required. We also require the Conda environment. So mini Conda is what we are using. So mini Conda is what we will install there. Apart from that, what else do we need to do over there? We need to install the agent. Like we have to install it over there so it can communicate with the cloud. That's what needs to be done, right? So once the agent is installed, we need to configure it. Like install the agent and then configure that. Configure it and then run it. Run means like start listening to the jobs. So if pipeline wants to execute, it will listen to that job. So what I have done, I basically have these scripts with me. I'll just give you a walkthrough of that. We will install the Azure CLI first. So this is, I will just curl the Azure CLI from the repository. We will install that. So CLI first. Then we need to install the Python. So we'll install this Python environment. So we will install Python 3. We will install Python pip as well. So I have the pip here, like install Python 3 pip. Then the mini conda is having few steps. Let me run this much and then I'll show you. I'll run the mini conda as well. So okay. So it may take few. So what are we doing right now? Let me just give you the walkthrough. In the meantime, it runs. We are the Linux machine is there. Where is this Linux machine? Like, if you are curious about that, this is running in my Azure portal right now. So this is Azure portal. And what I want is that Linux machine to get connected to Azure DevOps. Like this should connect to that. So I am installing the agent here. So it starts talking to Azure DevOps. That's what we are doing right now, right? Okay. So CLI is unpacking right now. And I hope it runs. It should happen any second now. Okay. In the meantime, I'll just in the meanwhile I'll just tell you a little more about the other things which I will also be doing there. So now let it do that. I'll just go back to my uh, DevOps portal, and I just want to click on the repository. And you remember the repository where the code needs to check in. This repository, the one which is in this location. See over here, this one. So that repository is yet not created, right? So I just remember that I forgot that. So I'll click on import, and I have the repository location in my secondary screen in one notepad. I'll copy it from there. So the train and evaluate file, some sample files are available in that repository. So it is getting imported into the DevOps portal. There is one question in the chat. If we use this connect with Azure AD in case of organization on project setting, will we want to create service principal? Yes, we still will require service principals to be there. What is service principal? Thanks for reminding that we have not done it yet. So if you notice, uh, so this is my Active Directory. What I also have to do is the Azure DevOps portal requires rights. Without rights, things will not work, right? So if you are available, I'm pretty sure you guys are aware of service accounts. On-prem, we have service accounts. We have not exactly equivalent of that, but we have service principal accounts in Azure. Service principal. So I really require to make that like this. So let's say service principal account. And what we will do this to this service principal account, we will give some rights. Where do we want to give the rights? On the Azure portal. So the rights will go in this direction. See, like this on the subscription right now. So this is our back. Why? Because Azure DevOps require some elevated access in the portal to be able to do steps. So in the meantime, my machine is getting configured. I will just quickly go and create the service principal, uh, and I'll show you how it's done. Right. So I really require that. I'll just make it right now. So I'll go back to my Azure DevOps portal, and I'll click on the project settings, and the service principal option is available. Call as service connections, and we'll create one service connection. Now we don't require too much of access, but we require the access on the machine learning workspace. Like I don't require subscription level access right now. Now this is just one information for somebody who later on tries to duplicate what I'm doing. In case you get any error and you are unable to proceed by giving the rights on the machine learning workspace, which is a resource level rights, you can give it a higher level rights, maybe on the resource group, or maybe even higher on the subscription level. So in production, you can further think it through, like what is the minimum rights, just in time limited access which you want to give. But for your first time learning purpose, you may give more rights. So if you get any error, go for subscription level over here. That's the advice if somebody wants to duplicate what I'm doing. Okay, so what I'll do, I'll simply go to my machine learning workspace, this one, and the name of the connection is, I'm giving this name if the name is available. Okay, so what is happening right now? What is this step doing? It is creating that service principal in the Azure Active Directory. Like where I should be able to show you that. If I take you back to my Azure portal, if you click on this Active Directory over here, you will notice that in the app, under app registrations over here, under all applications, we should be seeing some names like that. So one of them is more recent. One of them should be the one which I did previously, but they looks like having the same name. But this is what this is that red dot is that. So the service account. Okay, now let's go back, and it got created. Let's go back to the Linux machine. What's going on here? Okay, now we were already able to install the pip over there. We want Miniconda. So I have the Miniconda uh, getting cloned from their repository. So I have these steps over here. So Miniconda 3 is what we are getting from there. I will just copy it and run it. Do you accept the license? Yeah, please do that. Oh, I have to type yes or no. Okay, so yes, great. Okay. Confirm the location. Yeah, okay. So unpack the Miniconda. Let me read the questions in the meantime. Okay, I so you can put the questions right now if you have the questions. Okay, great. So Minicon is also installed. So my dependencies are there in the Linux machine right now over here, and now we just have to install the agent. The customization is done, but the agent is not there. This black dot is representing that agent. So what we have to do is we have to get the agent from here there. So what I have done, I have copied this URL, and we basically will be just creating one directory. The agent will be there and we will install it inside the Linux machine. The steps are here basically. So what I have done is this is that the agent is available on this link, https azureedge.net, which is their sort of CDN type of edge. It's a tar file. We will untar it and we will install that. So I have just copied it, and I'm gonna go back to my Linux agent and install it. Oh, press enter also. Okay, great. So now what we have to do is we have to configure the agent. So now configure the agent means that we have to do some metadata handshake. So the VM should connect to the DevOps portal, the metadata handshake part. So to initiate the metadata handshake, we are going to run. There is a config.sh file over there in the agent, inside the you can say the compressed file, and that once we will run it, it will ask us the Azure organization server URL. So the server URL means like the agent should talk to what. So if you do this, you have to go to your Azure DevOps page, and whatever is the name of your organization, that you have to copy. So this is my organization name over here. I will copy that. I could have given it a better name, but I didn't thought it through much. So I will give it over here. Dev.azure.com will remain common, but your organization name should be after the slash. I also require for the metadata handshake, I also require some tokens. So I'm going to Azure. There is a personal access token concept here. I will go to this token. The previous one is still active. I'll click on anyways one more time. And this is my, let's say, personal access token for doing the handshaking. How much rights do you want? How many days should it be active for? Give your details. This is the token. I'm just copying it for now in my notepad before I lose it somewhere. And I think we are all good. Let's do this. So I'll go back to the agent. I want it to talk to the cloud. So it's saying, do you accept the license? Yeah, why not? Please go ahead. Server URL is this one. So this is my Azure DevOps portal. Is that authentication through personal access token? Yes. Where is the token? That's the token I got from the Azure DevOps portal for the metadata handshaking and connecting to the server. Great. Okay. Which agent pool will do you want have you do you want this to be registered under? So agent pool was actually the name which I showed you earlier. I'll just quickly go back and copy that. I don't have it in my notepad. So it was called as agent pool, like this. So like that. And these jobs I think are coming from my previous deployment. I was just checking it out whether it works out or not. So I'll just go back. I'll give this name there. Okay. And let's see if it connects to it or not. So what I'll do, I'll just run the agent and we'll confirm whether it talks to it or not. So let's do that. Okay, connecting to the server. and it should say listening for jobs. Okay, now if I come back, it should say active here. So let's go back. Let's click on agent and we'll refresh the page once. And okay, I think I didn't made it. Okay, so let's say new agent. Let me see where did it connect it to. Just give me a second. I think we have to change the name over there. That name is getting confused somewhere. So no problem. We may have to make one more. Let's go back and see if we can do that. And okay, or it may take few more seconds for it to connect. Let me try this connection one more time. So I'll just break this. Otherwise, we'll change the name. Okay, so let me see if I can remove it. Yeah, why not? Remove it, and we'll add it one more time. Okay, successfully removed. Great. So let's go back and see. So hopefully this should be not connected to that. And I'll just go one page back and I'll just quickly see if I can just remove it. Okay. And maybe try to add one more time. Let's see if it goes with the same name or not. We'll come to know. Okay, we'll give it a new name. That name is already taken. So let's say, okay, so let's say pool 2. And I will remember to give this in all the other locations wherever required. So I'll say create, and now the overall steps sort of remain same. We just have to connect to the correct pool. So I'll go back to my Linux machine and I'll run the config file again, and I'll do the same process one more time. Server URL remains same. Over here remains same like this. Personal access token, yeah, sure. Take this and connect over there, and please connect to the pool number 2 now. Okay. So enter the pool, this one, and that's the pool now. Okay, so now which folder? Default folder. And now please listen to the jobs. So I'll go back and I'll run it. So if you notice now what it should do, connecting to the server, listening for the jobs. Okay, now if we go back and refresh the page, we should see something there like that. Like it should say online and active and all that. What I think I found the mistake which I did. What I did, I was supposed to give the agent pool name. I just pressed enter, so it took the default location. So what's the default location is this one over here. So if I just take you one page back, this is the default agent over here. So the agent last time must have registered over here before we removed it. So it got registered in this location. Right, that's where it went. So no problem. Now it is inside the agent pool 2 as such. Now what we will do, we have the Linux agent in place. We want to create the pipeline now. Now the pipeline will take some time to run. So what we will do, I'll make the pipeline first. We will run it, and then on the way we will sort of discuss it out. So I'll just zoom in over here. So my pool name is not agent pool. We don't have anything with that name now. We have this pool 2. Uh, let's use that one. So I'll just edit this. It must not be in the edit mode. Let me zoom in into the browser so I don't have to do that like this. Okay. So hopefully the screen will be visible. So I'm just connecting to that particular agent now. So let's change it here. Which resource group did we deploy? Let's go and have a look at it. So we deployed in the resource group called as MLOps. Let's copy paste. So this is uh, the resource group. What was the name? Okay. What was the name of the machine learning workspace which we deployed? Why are we doing this? This is that purple color machine learning workspace. So we can use the same workspace. So it doesn't take 15 more minutes to get created, right? It takes around 10 minutes, not 15. So it won't take 10 more minutes. It can use the same, uh, that one, purple one. So name, we'll just go and have a look at the name. It was called as, something Shivam AML workspace. So I'll just go to my Azure portal and I'll just quickly copy the name from there. Yeah, this one. So that is the workspace. We'll copy that and we'll put it in the right location there and remove the space. What is the experiment name? This experiment will get created in the Azure machine learning workspace in future. The cluster name is AKS1 and so on and so forth. I'll just commit it once. Okay. So what I'm doing, I will run the pipeline because it will take around 15 or maybe 17 minutes to run. While it runs, we will, I'll take your questions. We'll go through the stages. We will do few more extra steps and then it will be ready and we'll do the next part. So what is this pipeline? We are creating the build pipeline right now, this part, right? Okay, so I'll just run it once and then I will show you what I have done. So yeah, please run that. Start running it because you will take a long time to run this. Okay, so now if you notice, we have clicked on this and it's saying like job is queued, right? So hopefully if I go here, it's saying running the job, see, in the agent. So I hope the things are, I feel that things are running fine. It will take some time. So if I just take you back and click on the job, if you notice it is doing all of this, uh, like it is initializing, creating the MLOps, installing something, attaching the folder, creating the compute cluster, run the pipeline, and all that. So this is the time when it is running. We'll go and have a look at that. So I'll take you back to my repository. I'll click on the pipeline which I ran and I will zoom in here and we'll walk through the code. We'll walk through these stages over there, what steps are going on, right? So if you notice, the first thing which we are doing is we are installing the Azure CLI ML extension. Lot of inline script which you run require Azure ML CLI. Like, see, there is one thing called as PowerShell. We have Azure CLI, and we also have Azure CLI for machine learning. Previously, I have installed the Azure CLI in the VM. I have not installed the machine learning version of it. So that part is what we are doing. That install the machine learning CLI. So deployments, you can get the deploy some compute targets, and all those steps can be done. So uh, we are installing that first. Now we are attaching the folder to the workspace. So what happens in this step is basically okay. So what happens in this step is basically uh, in the here in the Azure machine learning service, one experiment will get created. Experiment is more of a like it's sort of a wrapper where everything will be there. Like if you run 5 versions of your code, then everything will be there inside that experiment. Things get logged over there. So inside this experiment, we are attaching one folder, and inside that folder, one configuration file will be there. Like that is the soft step which happens over there. So this configuration file is having the information of my AML service. So what is that configuration file? Can I show you that? It is this file. So if I take you to my Azure portal, over here you see this config file. This file is what will be there inside that. If I open it up, it should open somewhere. Okay, it opened in my secondary screen. So that folder will have this information. The In which subscription do we have to connect, what is the name of the resource group, and which machine learning service is Azure DevOps connecting to, or where do we their communication happens to. That information will be there when we attach the folder. Now that is one of the important steps. If you don't do it, you will get hell lot of errors later on, because of it will say I have no idea where I'm connecting to. Now what else do we do? After that, if we go back, you will notice that what we are doing is we are sort of we are creating the AML compute target. So this is that step, the red one, where that cluster is getting created. We have done it before just to save few minutes, so that part is already taken care of. It will just use the same one. What we have done pretty smartly, we have given the same name. AML cluster was the name which I gave earlier, just to make sure that it doesn't take few more seconds to run that. Now after that, what we are doing, we are running the machine learning part of it. We are training the model. Now when you train the model, there are two steps which are going to happen over there. One step is where we will train, the second is the evaluation step. So the training and evaluation, I will just duplicate my screen one more time, and I will open the, let me zoom out slightly, it's difficult for me to have a look at that. Okay, so let me just think it through. Okay, where did, is it available? Oh yeah, okay. So yeah, this is the training file, that is the evaluation file. We'll have a look at that also in some time. I'll walk you through that. But these two files are what is this is the first step, that's part of the second step. Dependencies are here. So let's open these. Let's have a look at that. So okay, so let me go through the dependency. So anything which you require, uh, like we are using keras, we are using tensorflow, scikit-learn, panda. So all the dependencies are defined in one file. All the like this is the actually this is one of the master file which is running other files. So if you see what is it knows like where is the dependency file available, which base image of Docker are we using, where we are on top of which we are putting the machine learning model, and then finishing the containerization process. This is that part of it. uh, and if I just give you the brief of it, this is where we discussed that the training file and the evaluation will come together to do the you can say the training will happen and the model registration will happen in the registry. So what I'll do, I'll just quickly see how much time it will take, or otherwise it may happen for a longer time. Let me, where did it run? Okay, here. So if you notice, right now the training is going on. It has been 1 minute for the training to be there, so it will run for next 15 minutes as well. So in the meantime, what we will do, let's have a look at the code. Let's have a look at the training code. So we will let it run, and I'll just show you the code as such. So I need one development environment. We'll go to the compute instance. So and we'll open the Jupyter notebook, and okay, and let's quickly git clone the train file and evaluate file, so we can have a look at that. And so this is the development environment. So in the diagram, where have we put that? In the diagram, we are on this step here, compute instance. We have the code copied inside it, and we will have a look at the code right now. So let's say the train.py file and the evaluate files and so on and so forth, this part. So let's open a few of them. So the notebooks are here. And so this is that the notebook. And I'll just do one thing. I will okay, let me have a look at. So okay, if we just have a walkthrough of it first, we are installing TensorFlow. Or let me do one thing, let me run it and then I'll explain it. So it will may take some time to run. So see, DevOps pipeline is doing its own thing. We are just having a walkthrough of the code. This step is not required if you are running your DevOps pipeline. Anyways, it is running it. We are just having, in the meantime, we have around, it will take 10 more minutes maybe. So in the meantime, we are just having a look at the various steps it will be going through. So some installations are going on uh, as such. We are training the deep learning model. Now the log, I'll just give you a gist of it. And right, so this is where we were discussing about that the technician will be writing the description of the vehicle, and then on that description of the vehicle we have to do some sort of classification where compliant or non-compliant will be there. So if the description uh, written by the technician looks like this: manufactured in 1985, made of steel, good condition, non-compliant because of the year over there. We have labeled data. We are doing supervised learning right now, and if you notice, good condition carbon fiber, manufactured in 2010, then compliant. Steel component manufactured in 1995, then non-compliant. So I'll just sip some water. Okay. So the labels are basically 0 are non-compliant, 1 is compliant. Binary classification is what we are looking for. So so we are using Azure machine learning to train that. The DevOps pipeline is doing it right now over there, and uh, basically we are create so machine learning workspace is already created. We don't need to create it again. It will just connect to the same one. There's the same thing which is there in which DevOps pipeline is doing. The cluster is also there. This part is this part over here, where the cluster, the green part where the cluster comes up, and then the cluster is there, and then the training data set. Basically we are using the word embeddings right now. So this is that word embedding part, and this is where this is where everything combines together, and it runs remotely. uh, and this is the train.py file, the main the file as such, where we are using that keras right now. We have some vocabulary, we have some maximum words, we have the dimensions of the embedding as well. We are using some smaller sample data. This is where the machine learning part happens. We are breaking the data, as you already must be aware of, and we are simply training that model. So we have that embedding layer, flatten, dense, another one with 32 filters. We have this another one with this 32 neurons, 64, 32, 1 sigmoid for that binary classification, for that 0, 1, and model.summary. So all those details will be there. Now this is where we are running the experiment, and it will just get submitted to that machine learning workspace like that, which we are just manually doing it. We don't need to do it. We're just having a look at the code because ML DevOps pipeline is anyways doing it right now. The build pipeline is doing that right now. And uh, oh, I think, so okay. So basically it's still running. That's why we got the error. It says it not found. So let's do one thing. Uh, we can add one wait command here. It doesn't matter. So let me quickly put that. So wait for completion, then you run the next step, because obviously see, the previous step has not completed yet. So obviously you cannot do the rest of it. So wait for completion, then do it. So let it run. Okay. Now, in the meantime it runs, I'll just give you a gist of the Open Neural Network Exchange. This is one project which Microsoft created. They open sourced it now. The Open Neural Network Exchange ONNX model is a type of you can say format in which you can convert your trained model, and ONNX gives you performance boost during inference. The boost will be there. You can say. 2.5 times to maybe 200 times, and so on and so forth. So open neural network exchange is something which is recommended whenever you are working, because it reduces the requirement of the development team to, you can say, of the data scientist to properly or completely, or it removes the need for them to correctly tell the dependencies to the one who's deploying it in the deployment target. So dependencies are now removed. So if I convert, imagine if I use Keras to train one model, I need TensorFlow because Keras is part of it now in the deployment location as well. But if you convert into Open Neural Network Exchange, then you don't need that. You just need the ONNX runtime to be available over there. So we are using it as and so and so forth. So this is what that DevOps pipeline is doing in this part, in the build part. So Linux machine using AML service, training the compute cluster, running the pipeline, and so on and so forth. So what I'll do, it will take some more time. We haven't finished it, but because we have around 30 minutes left with us, I will start making the release pipeline. But we will make sure that we will see that how can we will not be able to run it. We will wait for the previous one to finish, then we will do the next part. But we'll start the I'll explain the steps over there, like what step number one, step two, step three, and so on and so forth. That part we can definitely start with that. So this pipeline is still running. Let's go to the release pipeline. And in the meantime, I will just take you back to my Azure portal. It has been 9 minutes. Okay, let it run. So I'll take you to the pipeline section. So after that, we were supposed to make the release pipeline. We have no pipelines over there. We'll say new. And let's give it a name. So I'll give it a name. Let's say production. So production, like that, production release. So what are we supposed to do? We are supposed to use the Linux machine from the previous step, and two stages. Stage one is this QA environment. Stage two is the production environment. So two steps pipeline is what we are supposed to work with. Now the previous artifact is not ready, so that is where we are still stuck. We are waiting for the previous pipeline to finish. So what I'll do, I'll configure this artifact in the end. Let's do the rest of it, and we'll come before running. We'll come back and do the artifact part. So this artifact is actually the output of the previous one. Like the build artifact is supposed to be the input of the next one. So we'll wait for it. Okay, let's go to the stage empty job, and we'll give it a name over here. So let's say deployment, testing deployment as such. So over there, and what are we supposed to do? Which agent do we want to use when it runs? We already have it. We will just want to use the same one, and I'll select it from here. It is called as machine learning agent pool 2. This one, that's the one I want to use. And okay, so what steps are there? I want the deployment to happen. So if in case the Azure CLI is not installed, we may have to reinstall it. So what I'll do, I will just go for, uh, let me think it through. Okay, so I'll click on it and I'll say I need some version. Display name is Azure CLI. Subscription is, I'll use the service principal for the subscription connectivity here. If in the build agent, if CLI is not installed, you install it again. So that's what we are saying, that if in the self-hosted agent, if the CLI is not there, reinstall it, uh, like that. So okay, for arguments we don't need anything, and yeah, rest we will leave default. Okay, so next step. So we are looking for let's say machine learning here, and it's called as deploy machine learning. I will just quickly try to recall the name. Yeah, Azure machine learning model deploy, like that's the name. So where are we deploying? This is where you have to specify the target location. Where do you deploy that? Like here or AKS and so on and so forth. So we will say that do the deployment. So Azure machine learning model deploy. Okay. in the Azure subscription do it. So that's the connectivity, metadata handshaking part with the, what is this? This is the name of the service principal. That red dot is that over there. So, um, okay, yeah, this is where I basically have the file with me. So there is not, see, there are few like you have to provide how will it be done, right? So that particular file is available in the I'll just show it to you. Maybe I think it's open somewhere here, and in the, let me just quickly have a look at that. This is what we are doing here. We are running this particular YAML file. So this one. So what it does, it is okay. So it is actually, we are having 3 CPU core and 15 GB RAM in the ACI instance. Similarly, we have one file for AKS as well. So this is the Kubernetes file where we are saying that uh, that we want to do the authentication enabled. We want application insights to be false right now, which we can enable later on. Any timeout period can be defined for the purpose of scoring. How many concurrent requests can come per container? This is where your throughput will be defined as such. What is the queue wait in millisecond, and is SSL enabled or disabled? If it is enabled, you have to do further configuration to bind the SSL certificate as well. So this is the AKS deployment files. So what we'll do, we'll just go back and I'll close the unnecessary tabs. We are using the, uh, let me just confirm that. Yeah, okay. So sorry, this is not exactly, oh, yeah, ACI instance like this. So you'll get it like that. Like where do you want to deploy? ACI, AKS, and so on and so forth. And the YAML file is actually referred here. So I'll just give you the path of it. So we are using the ACI deployment configuration YAML file, and you have to give a name of the deployment. So whatever name you give here is the name of your ACI there, that one. Some customized random name, but that name will be this one over here. So I have the best name in the world called as test. Okay, so what happens if I run it 2 times? Then overwrite. Otherwise, we have to handle that. So we are saying that you deploy in the same, you overwrite the previous one. If I don't do this, then you have to think about how will you do a rollout. Like in case you do a rolling update. So that's where you will get more in. You can say you have to where the Kubernetes knowledge will come into picture, not really machine learning. So I'll say overwrite right now, and okay, save it. So let's go back. Let's go one page back and let's do the production part. Let's see, is the artifact ready or not? No, it's still running. I think it will finish at 17 minutes. So we just have to wait for a few more minutes. So I'll clone this and I'll say that you are the production part of it. Production, like this. And we want approval. Uh, Before going in production, we want that pre-deployment approval. You see this one, pre-deployment approval. So how can you do that? This pre-deployment approval can be configured from like that, pre-deployment approval, and who will approve? Let's give some user from the Active Directory. So this person will approve that. So basically I have to approve it. And okay, so now, okay, so deployment location, this is where that AKS cluster is not loading yet. So it will take some more time for that cluster to be visible here. We may have to sign out, sign in. Let's have a look at the cluster health. It should be running by now, but it is not visible there. Okay, no problem. So we will wait for that to be visible. And in the meantime, we will test it out. So we are going for the production service. We are changing the name of the of that. We are saying that you have a name as such. So we'll give it a name. I have it something like this: compliance classifier cluster. And this is where we are supposed to change this file now to AKS, which is yet to be visible. So we'll wait for it. We'll come back and change it in some time. and let's save it. Oh, and let's say that this is the uh, okay, I think that's fine. Let's save it and go one page back to the pipeline, and we are yet not done. We are waiting for the artifact to be there. But the stages looks like that, like stage one, stage two. So the previous file is finally done. So what we have done is the previous build pipeline is ready. So if you notice over here, uh, the the model got trained, the model got registered, the model got containerized also. So where are they in the Azure portal? So if we go back to the Azure portal, we'll see the entire uh, details. So let's go and have a look at the registered model, the the data as well, right? And let's have a look at that. Then we'll come back and do the next part. So if I take you to my Azure portal, like where is the output of all that, right? So if I take you to my machine learning service, the data should be in the data set. So here, so this is the connected car component data. The experiment was called as quick start. Remember, the name was there, quick start MLOps. So this is that one. The We can have a look at that. So the runs were there. So run one, run two. So this is, so why do we have two runs over here? Some child steps are going on. So if I click on any one of them, we should be able to see. We haven't selected anything here. Discard. Okay. So if I just go and show you the step one more time, let me see if there is any more details. So this is that two-step pipeline I was talking about, where training and evaluation is visible like that, right? And okay, and the model is registered here. So this is the compliance classifier which got trained by the MLOps pipeline and is now the artifact which is registered in the machine learning service over here. If we click on it, tags can be put over there. So if we click on it, these are the tags over here. See, you can give the description, like which what hyperparameter was used, which algorithm was used, who trained it, when was it trained, which build pipeline did it, and so on and so forth. Any more details can be put in the tag. So it provides that proper repository part. We can deploy manually from here. Some other details are there, and so on and so forth. The deep learning model to classify the description of car component as compliant or non-compliant, the details around it. And right, let's complete the release pipeline and we'll run it as well, this one. So we'll go back and we'll go to the release pipeline. The artifacts were not there, so now they should be visible. So if I don't install the extension, this will not be visible. I really want that. So this is the, like, I want the artifact to be the trigger for my next step. So I'll click on the service connection, and my model is called as compliance classifier. Luckily it showed it. Latest version definitely, because the evaluation step only register if it is better than the previous one. So that's one good logic which you can put in your stages as well. So okay, add. Secondly, what happens if somebody doesn't see, there are two things. Do the release, if trigger the pipeline. There is one more possibility that somebody didn't do the artifact, but the code got changed somewhere. Some code got changed. So you can add multiple triggers here. Like you can say that, okay, what happens if somebody didn't made some repost code change in the master branch, right? So in the master or main, now it's basically main. So in main, somebody made a code change. Then what to do? So those type of things can be done. So the default branch is literally master, named over here. It should, but basically because of master slave, the name has been changed to main. Maybe in some time it will reflect here as well. Okay, so get the latest from the default branch, add. So this is my release pipeline, and we have it good enough. So we can trigger the entire pipeline one more time, like this full pipeline again, and that now should trigger that. So if I just run it, it runs in this manner. So what it will do, let's go to release one. Or you can do the entire flow again, like you do the build first and let the release trigger after it. But if I give you a gist of it, this is again listening to that self, it's see running the job right now over here. So the agent is being utilized to run the job, and it will take some time. This will take around maybe 5 or 10 minutes. This will also take 5 or 10 minutes to complete the deployment. I'll do, I'll quickly show you the backup which I had, uh, because the live demos generally may end up having some issues. So I had the backup ready with me. So I'll just give you the view of it. How does it look like? This is my another subscription. This subscription is totally different. So I'll go to the pipelines, and this is how it should happen in some time, like that, like stage one. Then I personally clicked on approval, then it went into production like that. So that's what we are expecting, and it will take some time for it to execute. So like this. Okay, so in the meantime, what I'll do, the release pipeline is already running there. So if you see, the one which we just configured is running. There is just one last thing which I have in the agenda with me. The last thing was, how do you do the monitoring over there? So there are two things. First, we have to enable the monitoring. If you can definitely enable it through the YAML file as well. I showed you that it was disabled earlier. You can also enable it using you can update the service. So what we want to do is, we want to enable the application insights like that, right? So it starts using the log. So how do you do that? They have provided the proper SDK to do it. So I'll show you that part. I will go to my backup machine and my backup subscription, and I just will go to the AML workspace, and I will show you how is that done. So let me think it through. Where have I kept it? Okay. Okay, so let's start that, and it should be in one of the files. Let me think it through. Yeah, model.telemetry. Yeah, great, this one. So uh, don't worry about the details, but there is one line which I just want to show you. It's pretty straightforward. So so what is this doing? Like, we want everything to get logged. So when somebody like if somebody consumes the model, see, then that logging should happen. So you have to enable it. It doesn't by default, you can specify is it true or false, but in case you want to enable it, you can just do it like this. See, the web service dot update application inside true. That's just one line I just wanted to show you. Not a big deal, but what this will do, it will basically, see, this is a service over here. So when you deploy something, it is visible here in the endpoint section. So the production service will get the application insights enabled. So when the enabling of application insights happen, everything will start getting logged. So if I take you to my application insights, this is my application insights over here, the monitoring service. If I click on it, I can click on the logs over there, and I can close this page and basically show you the logs from maybe few hours back. So let me say last, I think I did it 4 hours back. Let's run it once. So I did one backup creation. Oh, no, nothing is there. Oh, let me click on it. Okay, so now let's run it. Okay, so 4 hours back somebody consumed the model. What details are there? So uh, let me, oh, this is not the correct, let me just uh, close it once. Let me increase this to 12 hours. Okay, yeah, score, this is what I'm looking for, the like where the scoring was done, like the it was in the inference happened, batch mode inferencing or real time inferencing. Real time is what we are doing right now. So this is that real time inferencing. If I explore that, basically you will see that uh, the response was somewhere. Let me expand it once. It should be having something called as a prediction or something, like the response was some input value came, not really. And let me see where is the response of it. Okay, let's open one more. Oh yeah, this is the prediction. So uh, zero was like we had zero ones, right? So there's a probability output from the sigmoid function. So they have some probability of 0.58 of one class. So this type of output is what we are expecting. Like all the details will get logged, like who called, from where it called, and so on and so forth. So this is that monitoring part, like where things are getting the continuous monitoring is happening of the deployed. If we want, we can further do data drift monitoring on top of it. Data drift is basically if the model gets degraded, then it will uh, sort of we'll come to know if the degradation happens over there. So what I'll do, I'll just take you back to my test deployment still going on. We have few minutes with us. uh, Feel free to ask your questions. This is what I had for the session. This is what I, you can say, configured the MLOps, where we will do the build pipeline and the release pipeline, and where we are training one deep learning model. So today was not the focus on the deep learning part of it. It was more on the how things interact with each other. So if I just quickly recap what we have done, we have used the compute instances, we have used Azure repos, we have used some self-hosted agents, we have used service principals for metadata connections, or for authentication and authorization. uh, the Azure DevOps portal has been used to create the build pipeline. Azure machine learning service and all the internal services were used to train the model, create, to register the data, containerize it. Uh, the container registry is there in my subscription. It will get created. See, if I take you back in the resource group, it should be somewhere. So this is the registry over here, this one. So inside this registry is what we are expecting, that image to be there. So these are those images. So it doesn't look very fancy, but this is that, this part, the registry part of it. And right. So that's the release pipeline, and we did the deployment. AKS is really not visible yet right now. It will take some more time for it to be visible, and we can do the application inside monitoring on top of it. So this is what we have for the entire scenario. There's one question in the chat. Can you please give us the GitHub URL you used to clone the previous environment? I will do that. Let me give me a second. So I will just do that. In the meantime, if there are any other questions, then let me know. I have the URL with me in the secondary screen. Okay, so these are the two repositories which I have used. It's going in the chat. That's one. Let me see, where is the other one? Okay, and this is the repository which I cloned earlier. The one which is coming now is the one which I cloned earlier. Use that. Okay, so you can put your questions in the chat. This is what I had for the session. Now, just before we wind up, I just want to show you that we also have upcoming sessions. So if I just take you to the company page, you will notice that we have the upcoming sessions on uh, Kubernetes as well. It's next week on 14th. So please join for the Kubernetes session as well. And in case you are interested in the uh, if you're interested in the data platform, but on GCP, then there is one session on the ELT and ETL using data fusion. Data fusion is similar to Uzi, Apache Uzi, right? Similar to that. So you can join for that session on 28th September as well. So the Kubernetes session will be taken by Mamta, and the link to join the session is going in the chat. You can use that one to join, and this is on 14th. And then the data platform with Google GCP Google Cloud Platform is basically after that on 28th September, where we will discuss how to make the data movement pipelines in the Google platform in the GCP as such. So over there now, let me just take few questions now. So those who have questions, please put them in the chat window and join us for the upcoming sessions as well. Okay, now in case we have the upcoming session on, I think I have skipped few of these. Take you back to my previous slide over there. In case you have any requirement, this is where the self promotion comes, right? So this is that part. So in case you have requirements of any training or consulting, you can definitely reach out to us on the sales ID. I will put that in the chat window as well. We will also drop you an email with the recording link. So please check out the like. Don't worry about the recording link. The email will go to everyone, and the email will most probably will go tomorrow or maybe on Monday. So everybody will also be getting the recording link and as well. Okay. So if you have questions, please put them in the chat window or okay. Let me go through the chat once. Okay, so those who will have a look at this session later on, the recorded ones, if you have any questions in the future, if you get stuck somewhere and so on and so forth, you can just ping me on LinkedIn or on any other platform. I will help you out with the details or any troubleshooting on steps which can be done. So you can reach out to me or anyone from Tech Scalable to in case you get stuck later on. Okay, then thanks everyone for joining in. I'll see you in the next session. Join us for the next week's session on Kubernetes. And thanks for joining in. Have a nice day or have a nice weekend. Thanks everyone. Bye bye.